What's up, guys? My name is Francisco Rivera D6 from BSCO E43, and this is my review on the study, well, a case report of NASA with the Mars Climate Orbiter Failure Board. Uh, what is the report all about? The report is about the Mars Climate Orbiter mission failure and the subsequent actions taken by NASA's Jet Propulsion Laboratory, uh, which is in response of the loss of the spacecraft. So what was the Mars Climate Orbiter? It was formerly known as the Mars Surveyor 98 Orbiter. It was a robotic space probe launched by NASA to study the Martian climate, its atmospheres and surface changes. The report highlights the contributing factors that led to the failure and identifying the areas where improvements should be needed to prevent similar accidents in the future. So, what was the reason for the Mars Climate Orbiter to fail? Uh, According to the case report, was primarily attributed to the translation units from English into metric units in their ground-based navigation software. Then communication with the spacecraft was permanently lost back in 1999, September 23, as it went into orbital insertion. So the Mars Climate Orbiter may have been brought too close to the planet, or it may have changed its trajectory and follow the orbit around the sun. So what were the issues of the case? So I first mentioned earlier the primary issue with its translational units in its ground-based navigation software. This error caused a major discrepancy in understanding the spacecraft's path in approaching Mars, which led to it straying apart from Mars's orbit. And other reports may be the inadequate consideration of the mission. The report states that there was insufficient consideration of the entire mission and the entire mission's operation, and this may have led to oversight of critical factors since it started off with the insufficient consideration. Therefore, a consistent communication and training is deemed probable to happen. The communication and the training team was not fully informed about the spacecraft's orientation in space, leading to a lack of accurate understanding and decision making. So, who was responsible for it? Of course, the metric units by NASA would be a fixed unit, but the translation for the spacecraft builder from Lockheed Martin would be absolute evidence that led to the mistranslations of it. And the machine's program actually failed to complete an end-to-end verification of the navigation software because of this. So the translation of these units were were never noticed. It became undetected and propagated through the system. It is said by the board that they recognized their failure and mistakes on the spacecraft projects. But usually the processes were in place and usually noticed before they become critical for the mission success. And the Mars Climate Orbiter also had its system generator function responsible for tracking and double-checking all interconnected aspects of the mission. But unfortunately, the machine's systems were not strong enough. That's why the handover of the spacecraft from the construction and launch team had their set of challenges because of this overlooked system. And other problems would be the communicational channels of the machine. That other communication channels were not actually operational. Supposedly there was an optional engine that should raise the spacecraft's path, that should properly follow through the relative orbit to Mars before its arrival. But fortunately it wasn't performed due to several reasons which were not listed. And the personnel actually involved were not sufficiently trained. Critical areas such as the relationship between the mission's operations and navigational characteristics. There was also inadequate process, so there wasn't even a solidified engineering requirements and technical interfaces to properly control and use this machine. These issues were collectively and properly outlined in the report. So how did NASA address this issue? It's been a question for others, but NASA took several actions to address and rectify its problems. So they actually went and assigned a new senior management leader to oversee the actions taken in response to the mission's failure. So it's actually an action that focuses on leadership and how a leader should be able to provide guidance and accountability, making sure that each process will never actually be overlooked. And with this incident, work plans were reviewed, especially for the related upcoming mission. During that time, the Mars Polar Lander mission, it was thoroughly reviewed and augmented, ensuring that adequate and sufficient considerations were made for the mission success, and that similar issues would be avoided. A NASA also applied a detailed fault tree analysis. It's an approach to identify potential issues, their causes, and their corresponding preventive measures to mitigate any risks. Then, especially with the issue that happened along the communications channels in the Mars climate orbiter, since those were informal, NASA increased the availability of a deep space network. It is for ensuring an enhanced communication with the spacecraft, and it plays a crucial role that provides reliable and continuous communication links for their data in deep space missions. And especially with what happened, peer reviews was actually implemented. So each member would have to have to give their surveys about each other. It involves subjecting the procedure to assessment and scrutiny by external experts so that their quality and their effectiveness would actually remain and be implemented, rather than having poor excuses or bad effects. And in regards to their big system engineering function and the supposedly considered engine, an enhanced focus on navigation and propulsion was taken into action. Since these are actually the primary tools that brings the machine into its orbit, specific measures were taken to improve their accuracy, reliability, and understanding. Then a red team review was established. It was it was a fully independent team to review and approve the closure of all subsequent actions. It involves independent experts in examining and validating the implemented changes and improvements. They are acting more like a watcher, making sure that all goes to plan and no unnecessary changes would come into play. And this, with the case of the Mars Climate Orbiter failure, it is absolute that the knowledge of embedded systems is highly important in space technology, because integration of different systems come into play. Even translation comes into play. Let's remind that embedded systems were or are actually specialized computer systems designed to perform specific functions within larger systems or devices. In context of space technology, embedded system absolutely plays a crucial role in the operation, control, and communication of spacecraft and space-based instruments. So, what are those reasons why embedded systems knowledge is essential in space technology? First, in terms of system control and operations, an embedded system is responsible for controlling and operating various subsystems with a spacecraft, including its propulsion, navigation, power management, thermal control, and communication system. Next is real-time responsiveness. Space missions often require real-time responsiveness where critical operations need to be executed with strict timing should also be able to they should also be designed to handle real-time tasks efficiently, which would increase their probability in ensuring their critical operations are performed accurately. Then next is the power and resource optimization. Spacecrafts have limited resources. They power themselves, including their including their electricity. Well, that's thermal, but other functions with memory and processing capabilities. Embedded systems enable engineers to optimize and utilize these resources, ensuring that efficient power management, memory, and its algorithms works properly. Optimization is critical for maximizing the machine's lifetime, and making sure that objectives are reached within the resource constraints and its time constraints. Another crucial reason for embedded systems in the space technology is its communication protocols. It plays a vital role in establishing communication links between spacecraft and ground stations. Understanding communication protocols, data transmission, and error detection, correction techniques, and mechanisms is crucial to ensure successful data and reliable communication in space missions. Embedded systems, as a knowledge, is of utmost importance in space technology. Engineers are enabled because of this to design and develop reliable, real-time responsive, fault-tolerant, and resource-efficient systems that are essential for the success of space missions. A deep understanding of embedded systems will let a machine be able to facilitate its own strength in terms of the spacecraft's control, instrumentation, and its communication system. It should be able to let it withstand the challenges of the space environment. So what are my key takeaways in learning this case report as a computer engineer? It's important to note that, as how simple circuitry works, each factor should be considered and processed properly, especially with the case of the unit conversions. It may be a small and temporal error, but the ever progressing data that it intakes leads into a more far off translation. And the embedded system is an effective and efficient way for implementing the machine, but with presence of it or not, the implementation of a system should nevertheless be the same. Its review, its implementation, its components should never be overlooked. The presence of a more advanced technology usually leads to comfort and ignorance, especially with the case that happened with the Mars Climate Orbiter. Embedded systems or not, systems should be taken carefully and with accountability. The well, there were many actually functions that kept me in this state, especially with how an actual orbiter is implemented with its engineering system, with its robust systems, its communication channels, and its verification and validation for the software and computer models. And it's also important with its to have a comprehensive system, since it is vital to consider the entire system and its post-launch operation as a whole during the design and development process. Ignoring or neglecting this holistic view and failing to account for all its aspects can lead to an overlook critical factors and potential failures. One which happened with the Mars Climate Orbiter. And sufficient training and expertise and actual communication will always be relevant in any mission. Well, such as mission operations, navigational characteristics, and anomaly reporting. Accountability matters in this professional field and its professional development and knowledge. And it is also important to understand your peers, to review them independently, and to validate with a validated process that should provide valuable insights and oversights that could develop or underdevelop a mission operation. Another learning, well, it's not learning but the realization that the case undermined the importance of learning from failures and incorporating the lessons learned. Well, it's not that they undermined, but from the start, before the incident happened, that they had to lost something big, which I don't know, roughly costs around 100,000, or I mean million, 100 million in a simple mistranslation and insufficiently robust system. Well, it's not robust, insufficient and weak system. So that's all my review and key takeaways for this case report. See you next time, and thanks for listening. Bye bye.